Excellent. Welcome, welcome, everybody. Come on in and have a seat. I think you'll enjoy this talk. So I'm going to be talking about real-time analytics and Kubernetes and ClickHouse, which is my favorite database. I'll explain why in just a minute. My name is Robert Hodges, and let me just do some intros here. Let's see if my clicker works. 1 second here. We seem to be having a revolt. Huh, weird. Okay. Yeah, a little bit about me. So you can read the slides, so I won't do that. What I will tell you is that I been using Kubernetes for about 6 years, started at VMware. And I was there for a number of years. Previous company that I ran, we sold to VMware, and so we went and lived there for 4 years before I came back to startup land. I've been programming for 52 years, or 52 and a half. So the weird thing is that is longer than the parents of some of my current employees have been alive. So, and if it makes me sound like a grandpa, I actually am. So the people I work with, our company, we have 46 people spread over 16 countries. About 2/3 of us are engineers, which is to say complete data geeks. Mostly, well, all kinds of databases, but specifically analytic databases. And we do a huge amount of work on Kubernetes. So I was explaining to somebody before the talk started that when I have to check that box for example, for Kubernetes talks, is this a user story or is it a vendor story? It's kind of both, right? Because we're vendors, because we provide a service, specifically hosted ClickHouse on Kubernetes. We also wrote the Kubernetes operator for ClickHouse that's very popular. It has over 1,000 stars. So we sort of are both users as well as vendors. And as a result, we've been using Kubernetes to run databases for over 4 years now, so our experience at this point is fairly deep. We run hundreds of database clusters on Kubernetes at this point. So I'm going to start by just introducing a real problem. So how many people work with GDPR? Have to deal with it? Okay. So you know what that's like. And so a real problem is, hey, we can't use Google Analytics because this thing is like written by the Antichrist. And so we're going to make our own, and it's going to be a replacement, and it'll be fully GDPR compliant. That is an analytic problem. And so it's characterized by data that arrives very, very quickly, often off an event stream. And by quickly, I mean millions of rows per second in some cases, or more. It is characterized by wanting to know that things, to have the data immediately queryable so that when something arrives, we know immediately that it has happened, and then the ability to scan the data, the historical data, to explore it. And that's exactly what you do with a lot of web analytics. It also describes a wide range of problems involving security, sort of security management, valuing securities in markets, dealing with observability, so on and so forth. So the core of solving this is to have a database that can match these requirements. And in our case, the database is ClickHouse. It's sometimes called a data warehouse, but I think a better name for it is it's a real-time analytic database. It is designed to ingest data very quickly and spit out answers very quickly, often in milliseconds. So it's kind of like a mix of MySQL in the sense that it's open source, it runs practically anywhere, it's very simple to run, and a proper data warehouse like Vertica. Is anybody here who's used it? It's or Snowflake, for example. I think probably most people have heard of it. And in that case, we have things like columnar storage, very high levels of compression, ability to parallelize, use all the compute resources to answer questions very quickly, and then to scale to many, many petabytes. So for example, Cloudflare, all of their user analytics run on ClickHouse. They're just one of many companies that use this quite heavily. So in our case, we wanted to run this on Kubernetes. So does anybody in this, does everybody here run Kubernetes? Also, you know this picture. Kubernetes is an orchestration system for container apps. And it's actually not a bad one. As this picture shows, you define You have an application. In this case, it's a ClickHouse server. It's got some storage. We define suitable resources in Kubernetes like stateful sets and PVs and things like that. And then they get mapped to real infrastructure. Kubernetes does a pretty good job of that. The problem is that ClickHouse is an interesting distributed application, which means it is complicated. So this is a relatively simple ClickHouse server, which has 2 shards. So that is to say 2 disjoint sets of data. And then each of those shards has 2 replicas, so 2 by 2. Plus it also has Zookeeper, because being a good distributed system and exchanging information, we need somebody to keep track of what is the actual state of the database, what are the parts of the tables that need to be replicated, so on and so forth. When you map this to Kubernetes, it gets ugly. So this is just a small example of the types of stuff that's going to go into the environment, need to be defined, managed, cleaned up, as the case may be. And we're dealing with clusters. So for example, in our cloud product, we have clusters that have 25 or 30 nodes. We have customers who are running this themselves. In one case, one of our customers runs something like 550 servers in Amazon. So these things are huge. And so doing this all by hand is obviously not going to work. So what we have is operators. Does everybody know what an operator is? So, and I presume you've used them for Postgres. For what database, or for what purpose?
I played with Mongo.
Mongo. Okay. So yeah, so Mongo, MySQL, Postgres, so on and so forth. We wrote starting 4.5 years ago. We wrote the operator for ClickHouse, and basically what it does is an operator sort of takes its name from the old name for administrators. They were called operators. In fact, that was my first job back in the 70s on IBM mainframes. And what they do is they define what's called a custom resource definition. So you make a new resource, and then the operator is responsible for managing it and turning it into Kubernetes resources, which will represent it out on the Kubernetes cluster. And they do this through a process of reconciliation where they look at your definition that you provided, look out at Kubernetes, and basically make changes so that what your definition says is reflected in the Kubernetes resources. So it's a great model, and it's made Kubernetes a totally great place to run data, because you can define the whole database, even a relatively complicated database like ClickHouse. You can define it in 12 or 20 inches of YAML. So very quickly, how you would install something like this to run ClickHouse, it's one line. You can just pull the YAML file out of GitHub. So I won't belabor that, but it's as simple as that. You can install it straight from GitHub. There's another thing you want to do. You'll install Zookeeper. Again, very simple. 2 steps here. Actually, 3, because I have to make a namespace. But again, bing, 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 you can do that, and Zookeeper will pop up. This is just one node, so it's just a dev example. And then we can bring up the ClickHouse cluster. And at the risk of running over my time, I'm actually going to do a demo of bringing up a database cluster. So let me go ahead and pull out of this. And we're going to hop out to Amazon. All right. So what we're looking at here is a namespace on EKS. So that's Amazon's managed Kubernetes. How many people are running in Amazon? Is that where are you? If you're not, so I only see a couple. Where else are you guys running Kubernetes? Are you doing it locally or Azure? Okay. I have to have a chat with you about how you like that. That's because we're going on to Azure as well. So and then of course you can run on laptops and things like that. So this is our current set of pods. I've actually got a couple of data warehouse servers already up and running. That's that CHI, that stands for ClickHouse installation. But what I'm going to do is I'm going to go and start another one. So let's go ahead and apply one. So this is going to bring up a 1-node data warehouse. So I applied that manifest. It's just some YAML. We're going to look at it in a second. And then we're going to watch what happens. And you can already see that within a second or two, we've already started to create the container for it. And in fact, I predict that within 40 seconds, this will be this thing will be up and running. So we're at 17 seconds. I'm going to just pop over and show you here, let me lay down the microphone. I'm just going to show you the text of this very quickly. It's very simple. So there you go. It's not even 12 inches of YAML. Of course, it shows it's about 5 feet on this big screen, but it's a very short file, and it has very, very simple structure. So by this time, we can probably go back, and believe it or not, yes, they're 54 seconds in. That server is up and running. Now, this was quick because we didn't have to do anything special to make it run. We'll talk about what those things might be. For example, allocating VMs. We'll talk about that in just a second. But anyway, it's that simple to bring up a data warehouse cluster, which can now process millions of rows per second, can give you query results in milliseconds. So let's go back to the presentation. Okay, so what's going on in there? So these custom resource definitions, the way we designed this was we kind of modeled it on stateful sets. So stateful sets, if you're familiar with them, allow you to manage pods and connect them to storage. So they have a template definition for the pods, and you can make as many as you want. Those are called replicas, and they have a template definition for the storage, which allows you to, for example, ask for EBS, set the size, decide whether it's encrypted or not, things like that. And just some of the things you find early on, just looking at this picture, for example, the number of shards. We have 1 shard and 2 replicas in this example. So it's as simple as that. If you had like 64, like 8 shards, 8 replicas, or 8 shards, 3 replicas, you just change the numbers. You don't have to make any other changes. And if you want to scale up, that's all you have to do is change the numbers. We're going to use templates to define the pods and the storage, and then we have a clause that tells us where our zookeeper is, so that's a dependency. What do those templates look like? In this case, they're very simple. We're just saying, hey, we need to run this container. There's the container name. That's going to get pulled from Docker Hub if it's not already on Kubernetes. And we're going to go ahead and define the storage. So in this case, we're going to ask for 50 gigs. And what's kind of cool about this is this definition I've just shown you will run on any Kubernetes in creation, at least everyone that I've ever tried. So it runs on Minikube, runs on EKS, it should run on AKS, so on and so forth, because it doesn't make any special requests to the system. And that's one of the things that's really cool about Kubernetes is you now have something where, for example, if you want to have development versions, you want to have staging versions, you want to have production versions, with relatively small changes or sometimes not even any changes at all, you can run them wherever you want. So as you build up into production systems that begin to go back and solve this problem, you actually have to be a little bit more thoughtful. So one of the things about databases is they kind of like knowing how much memory and how much compute they have available to them. And they also want to get kind of picky about storage, because storage is everything for a database. So one of the things that you have to be aware of is like, hey, what's the magic behind the scenes that actually that allows you to allocate a VM, for example, to each pod, and to maybe put that pod in a particular location, and what is the magic that allows you to get the proper kind of storage and the right amount of it allocated. So in this particular case, I'm running Carpenter as my provisioner. You may be familiar with that. It's a substitute for node groups. I like it. Actually, our SREs don't like it. They prefer node groups. I like it because it's really fast, but it's sometimes a little bit flaky. And then you have storage classes, which are basically definitions of different storage types, and then they connect to a provisioner, which will actually fulfill the persistent volume claim that's asking for a certain amount of storage type. So if we have this set up, and this is all we have to do to create these clusters, at that point, we can now do some kind of interesting things that just come for free with Kubernetes. Basically, we can implement separation of compute and storage. That's a really important property the ability to have a patch of storage that's controlled by a data warehouse and to scale the VMs up and down. So for example, go from 2 vCPUs in development all the way up to 64 or 128 when you're actually in production with tens of millions of rows arriving and constant queries. So we can do things like set the VM size, we can set the AZ, the availability zone that it's going to be in. We can also do things like set the storage type and the size, extend it at will, so on and so forth. I'm just going to give some simple examples of doing that. So, for example, I can take that definition and I can extend it a little bit. And what I'm doing right here is for the replicas, I'm now going to have different templates depending on where I want those replicas to land. So for example, I've named them Zone 2A and Zone 2B. These guys that we're looking at are running in US West 2, which means they're somewhere out in Oregon along the Columbia River. So I'm going to have a separate templates, and that means I can twiddle the pods and make them do exactly what I want in each zone. And in fact, if we go and look at one of these templates, we'll see that I've got the instance type, which here is M5 large. This is kind of an old and pokey instance, but does everybody know what well-known labels are in Kubernetes? Are you familiar with that term? So Kubernetes has this really cool, they're kind of like informal properties which aren't officially part of the definition, but they are known to, most of the Kubernetes distributions respect them. So for example, this instance type says that, hey, if you're running in the cloud, that means I want to go on this is a node selector, and basically says I want to be on an M5 .large type. Another one, this zone right here, that's another thing you get for free. This topology.kubernetes.io/zone, that will map to an availability zone. And what it'll do is it will not only look for a node that's the right VM type, but locate in the right zone. And so when this gets processed, Carpenter will basically see that the pod, which has these requirements, cannot be scheduled, and say, aha, I see you've been kind of waiting fruitlessly trying to get scheduled, so I'm going to make a VM that's of the right size in the right zone, and then you'll get scheduled. And we can then also do things like play around with storage. So for example, we can choose our storage class name on Amazon. If you're using EBS, you typically want to use GP3. You might do things like increase the speed of the storage, so on and so forth, and then increase the resource size. And one of the things that's really cool about EBS is that it extends automatically. So simply by changing this number from 50 to say 100, 150, 250, we're now extending the storage as high as we want. So we have a database, but a database is just the beginning. It's the core, as I mentioned. What we really want to do, if we're going to solve this problem of building these GDPR compliant web analytics, is we need to build a full analytic platform. So we call this the modern analytics stack, but it might include, for example, we've already seen ClickHouse and Zookeeper. Two other things that if you're running anything in Kubernetes, you probably want to run Prometheus because that's going to collect your metrics. And the ClickHouse operator actually has an exporter built into it, so it will automatically export to Prometheus. We'll use Grafana to show those metrics. It has a very good adapter to Prometheus and super good time series. It's really easy to go in, change the time series to look at different series. We'll add a couple other things. We might want to run Kafka so that we have our event stream just pasted into the platform and maintain it there, and that way people can just connect to it to dump the web analytics. And then finally, we'll use something called Cloud Beaver. With data warehouses or databases in general, it's kind of nice to have some sort of SQL tool to go mess with it, to create tables, to do quick queries, test things out. For that, we'll use Cloud Beaver, which is a containerized version of dbeaver. Has anybody heard of dbeaver? Okay, great. If you use databases, it's a great product. We're very pleased with it, along with Grafana, which is also excellent. So what we want to do is build this stack. It turns out that there's actually quite a few tools to do that. Is there anybody here that uses Argo CD? Okay, great. I'm glad to hear this. We find our users about 1/3, if they're Kubernetes geeks, about 1/3 of them are on Argo CD, and the other 2/3 are typically Terraform, sort of because they'll use the Terraform kubectl provider. But what you can do is you can combine. Obviously, we've got Kubernetes, combine GitHub, combine Argo CD, and you can build this stack. And the way that it works, for those of you that don't know Argo CD, is Argo CD basically is an enabler for infrastructure as code. And by that, I mean that you have a code definition, be it YAML, be it other things, that you are checking into GitHub, and you want to get those things applied to Kubernetes clusters somewhere out in a useful location. So basically, Argo CD will do that mapping for you, and it can handle things that are distributed just as plain old manifests, just a patch of YAML. It can handle Helm charts. It can also handle customize, which is a variation on manifests that allows you to tweak them as they're applied. And what it will do is it will just grab them, and you do a process of synchronization where you say, hey, here's the code in GitHub. Please synchronize Kubernetes so that whatever install you're using, Kubernetes now looks like what's stored in GitHub. So when you get this fully deployed, it looks something like this, which looks a little bit hideous in this picture because it seems complicated, but it actually isn't, because you can basically start very small. And what you'll do is you'll check in your definitions in Argo CD. What you do is you define things called applications, which define the components of your architecture. So for example, ClickHouse, the cluster will be treated as an application. The ClickHouse operator can be treated as an application. You'll define those up in GitHub. You will then point Argo CD to it. So for example, I'm using the command line to do this, where I tell Argo CD explicitly, hey, here's a project in GitHub. Go ahead and adopt that to get the application definitions. I can then explicitly ask them to be synced to Kubernetes, and then it just goes ahead and installs them. There's a lot more to it. So for example, you can define ordering. You can do things like automatically sync so that when you check in, like when a PR gets accepted in GitHub, it can automatically cause Argo CD to sync. So basically, you have this control mechanism that's completely synced with your CI/CD. So it's a pretty powerful tool, and as I say, about 1/3 of our users are using it right now. And that's it. That basically gives you the solution. So to come back to this problem and sort of wrap up, if you want to do this, just a few things. The core is ClickHouse. It's a really, really great database. And what you can do is you go get the ClickHouse operator, or officially the Altinity Kubernetes operator for ClickHouse, which avoids lawyers coming after us. And you just grab this. You can set up the data warehouse. It'll run anywhere that Kubernetes runs. It's very portable. But it's also sufficiently flexible that you can then apply it, to make it work with EKS. You map you have provisioners or node groups to map storage, use your own storage classes. So ClickHouse is the core, but then you use something like Argo CD or, as I said, Terraform or OpenTF, whatever it's going to be called, to build the entire stack so that you can build a full solution and maintain it afterwards. So if you want to get started, just go grab the operator, and this is licensed under Apache. So my cry from the heart is use it and help us make it better. It's got I think it's got 1,300 stars on GitHub. It's not as popular as a couple of the Postgres operators, but it's like about number 3 on the list in GitHub. Tell your friends about it. Log issues, send us pull requests. We have everybody from, just sort of hobbyists to companies like IBM who are submitting. And there's like one of the Chinese internet services for ClickHouse uses the Altinity operator, and they submit pull requests on it regularly. And then if you're going to build a complete stack, I won't read this through, but this is basically the list of mixings that are going into this. We're working actively on this blueprint that I alluded to, and adding in things like security, doing things like passing in secrets, ensuring they're properly encrypted, stuff like that. So with that, we're done. If you want to find out more about this, we can ask questions now. I'm around for the next 2 days. And, come talk to us. This is, we live and breathe this stuff. And, we love talking about it and meeting people who, are building these systems and need help. So that's it. I'm done. Thank you very much. Any questions? Yes.
It's always meant to be baked and flanked by Zookeeper, or it can work without Zookeeper, for example?
Yeah, that's a great question. So if you operate it as a cluster with replicas, you need Zookeeper. Or actually, ClickHouse has a replacement for it that's called ClickHouse Keeper that re-implements those APIs. And the reason for that is that if you're replicating things, you typically need somebody to maintain a scorecard that's consistent of the parts of the table that have arrived and need to be replicated. There are ways to build clusters that don't use Zookeeper. In that case, you could just have a bunch of servers that all independently read from Kafka. And then if, it's called stateful replication. Basically, if they all read the same records in the same order, you would kind of expect them to have the same content. So that's another way that people actually build these systems. Yes, sir?
Is it best practice to have a Kubernetes cluster dedicated exclusively to ClickHouse? Or do some people run other applications and use different node groups, or just throw it all in there?
Okay, the question is it a best practice to run this in a single Kubernetes all on its own with just the data warehouse, or can you put other things in there as well? The answer is yes. So you can do it either way. What we find is that, because what's really important for databases is that they have isolation at the VM level. So that's why I made a big deal of being able to, use the well-known label for the, to allocate a VM for each server. But then beyond that, you could have a flood of other resources. And in fact, I would say on balance, people who are building these stacks, they tend to put them all in one Kubernetes cluster. Because they're a little bit, Kubernetes clusters do require extra work to maintain, so you don't want to multiply them unnecessarily.
Thank you very much.
Any other questions?
What are the backup options?
Excuse me?
Backup options.
What are the backup options? Well, it just so happens we are the maintainers of ClickHouse Backup, which is a command line tool. So that will basically freezes the tables, which basically means stop so that they don't change underneath you. You can then copy off the files, stick them in object storage. So that's pretty popular for data sets, say under 20 terabytes. As they get larger, what people do is they will often use file system snapshots. For example, on EBS, or if you're on GKE, you have a similar thing for PDSSD. So those are two common options. A third option is not to back them up at all. Believe it or not, because you just keep a bunch of replicas. And the reason this is not as stupid as it sounds, because these data warehouses often manage enormous amounts of data, like in the range of petabytes. So if you could back them up, you would have problems ever restoring them. So what people do is they just keep enough replicas that hopefully they all won't die at once. That is actually a fairly common practice. I will say we are working on backups for object storage. So as people start to inject more data onto object storage, you have additional options like replicating the object storage to another location. So I think I'm out of time, and yep. Thank you very, very much. I'll take more questions if you have them, and yeah, thanks for attending.